Okay, then year 11, here's your lesson on area and volume in 3D similar shapes. So I'm going to start off by drawing two cuboids. Alright, so both these cuboids are going to be similar. So that means the bigger one, which I'm drawing now, is going to be an enlargement of the smaller one. So if I just pick some random dimensions, I'm going to have a width of 2, depth of 3, and a height of 5. Okay? And then my enlarged cuboid, I'm going to enlarge them all by a scale factor of 2. So I'll have a width of 4, depth of 6, and a height of 10. Okay, so my length scale factor is going to be 2. So I'm just doubling all the sides. Okay, so we just shrink that down, move that out of the way. Okay, oh, here we go. So first of all, I want to look at the link between the area then. And what I want to look for is to see if there's a pattern between the scale factors for the area and the scale factors for the volume of these two shapes, and how that links back to the scale factor for the length. So my area of that front rectangle is going to be 10. So I've just done the width times the height. That's 2 times 5. So we just shrink that and put that underneath that little cuboid. Okay, and the area then of the front face, that rectangle, the bigger cuboid, obviously is going to be 4 times 10, which gives me 40 centimeters cubed. Okay, so just multiply those two lengths together to get me that calculation. So you can see straight away, look, that the scale factor is not 2 like it was of the length. Alright, so if I compare those two areas, I want to find the scale factor between them. So I'm looking for what I multiply 10 by to get a 4. So my scale factor of my area is going to be 4, which is 2 squared. Okay, now if you think about that, it makes sense because I'm multiplying two dimensions together, so two lengths, 2 times the 5 and the 4 times the 10. So both of those lengths will be multiplied by 2 because my scale factor is 2. So therefore my area gets multiplied by 2 twice, so those two dimensions. Okay, so let's do the same for the volume now. That's the volume of the smaller shape is just going to be the length times the depth times the height. So that's going to be 2 times 3 times 5. Okay, so that gives me 30 centimeters cubed. Alright, we just put that under there with the area. I'm going to do the same for the bigger cuboid. So the volume of my bigger cuboid is going to be 4 times 6 times 10. Okay, so that's going to give me 240 centimeters cubed. So we just put that under there, that other cuboid. So now I want to compare the volumes 240 and 30 to work out the scale factor of the volume. You might have already guessed what the scale factor is going to be, or worked out yourself by now. Okay, so I'm just going to do 240 divided by 30 to get my scale factor. Okay, and if you work that out, you'll notice that the scale factor is 8, or 2 cubed. Okay, so it's the scale factor of the length cubed. Okay, now again, that makes sense because if you think to get a volume, I'm multiplying 3 dimensions together. So each of those dimensions has been enlarged by a scale factor of 2. 2 has been multiplied by 2, the 3 has been multiplied by 2, the 5 has been multiplied by 2. So each of those original dimensions in the smaller cuboid has been multiplied by 2 cubed to get the volume in the bigger cuboid. Okay? So just to generalize this, okay, if the scale factor for your length was x, then we can say your scale factor for the area is going to be x squared. Just think along the lines of its 2 dimensions. That's why you're squaring the length. the scale factor for the volume, it's going to be hard right now, would be x cubed. Okay? Right then, so now that we know that, now we know the relationship between the scale factors for length, area and volume. It's basically just the scale factor of the length squared is going to be the scale factor for your area, and the scale factor for your length cubed is the scale factor of your volume. Now that we know that, we can go on and solve some problems involving scale factors in 3D shapes. Okay, so we do question 3 from the first exercise, and the first part is asking us why are these two triangles shown similar. This is a recap of a topic that we did in year 10 called similar triangles, and basically two triangles are similar if the angles in those both triangles are equal to each other. So I've got 13 and 80 degree angles here, so my third one is 70, and the smaller one, look, if I do 30 plus 70, which is equal to 100, take that away from 180, my missing angle is 80. So now we can answer the question, why are these two triangles shown similar? Well, the corresponding angles, the 80, 30, 70, is the same in the both triangles. Look, so the bigger triangle is an enlargement of the smaller one. Okay, so our answer is just going to be, because the corresponding angles are equal, therefore the triangles are similar. So part B wants us to work out the area of the bigger triangle, given the area of the first one. So the first thing we need to do is work out the scale factor of the length. Okay, so all I'm going to do is compare the corresponding lengths that I've got for the two shapes, okay, and divide the bigger one by the smaller one, and that'll give me my scale factor. So 6 divided by 4 is 3 over 2. I'm just going to write that as a decimal to make it a bit easier to work on the calculator. So my scale factor is 1.5. So therefore my scale factor of my area is going to be 1.5 squared. So therefore my area of the bigger triangle, T2, is going to be the area of the smaller triangle multiplied by my scale factor of the area. So it's going to be 3.8 multiplied by 1.5 squared. That's it. That's all there is to this work. Okay, so my answer is going to be 8.55, and I've rounded that to 3 significant figures. Okay. Right, let's do one more question. Okay, so this question now is from the next exercise, and this deals with volume. So we're told that the cylinders are similar this time, and we're going to find the volume of the larger cylinder. We've got the volume of the smaller one is 100, we've got a length there of 8, and a length there of 16. So, again, first thing you're going to do is work out the scale factor of the length. So that's going to be 16 divided by 8, the bigger shape divided by the smaller shape, so that gives me a scale factor of 2. So therefore, the scale factor of the volume is going to be 2 cubed. So we're dealing with volume this time, we're dealing with 3 dimensions rather than 2. So it couldn't be any simpler. My volume of that larger cylinder is going to be volume equals 100, the volume of the smaller one, multiplied by my scale factor, 2 to the power 3. So the volume of my biggest cylinder is 800 centimeters cubed. Okay, nice and straightforward, nice and easy. Right, we can do one more example and then you can get on with the work that I've set you. Right, so for my final example, I've picked the more strangest question in the exercise, dealing with the volume of 2 cats, which sounds quite disgusting, doesn't it? So this time I've been given the volume of the bigger cat, which is 3,500 centimeters cubed, and the volume of the smaller cat is 2,000 centimeters cubed. And we want to find the height of the largest cat. Okay? So these cats are identical, enlargements of each other. It's a bizarre science experiment. So, first of all, let's work out the scale factor of the volume. The volume of the large cat, 2,500. The volume of the smaller cat, 2,000. The scale factor for my volume, which is 1.75. Okay? So, this time I'm going to be working backwards. So if I've got the scale factor of the volume, to work out my scale factor of the length, I'm going to use the fact that that length would be cubed to get my scale factor of the volume. So I would do the opposite. My scale factor of the length is going to be the cubed root of 1.75. That's going to give us a large decimal number. So, hang on. Let me just move this out of the way and view. It's going to give us a large decimal number, so I'm just going to leave it as cube root of 1.75 for now, and leave my calculator to do the rest. So if I take the height of the smaller cat, so that's going to be 30, multiply it by the scale factor of my length, which is the cube root of 1.75, that'll give me the height of that larger happy looking cat. It's 36.1521 blah 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 blah. So I'm going to round this number to 3 significant figures. So my height of the larger cat is going to be 36.2 centimeters, and I've rounded that to 3 significant figures. Now there's an idea, remember to do this in your exam, for example. Write down the unrounded answer first of all, and then do your rounding to the degree of accuracy that the question's asked. Okay? Right, so off you go. Practice the 2 exercises in the textbook until you're confident that you can solve these kinds of problems. Do as many of them as you want until you're confident, and then can you work through the PDF of exam type questions on this topic that I've set you on Showbie. Okay, good luck.